Kia ora koutou, and welcome to our next video, our bonus video, looking at how large language models are developed. In this example, I'll give a very short, simplistic demo around understanding the fundamental principles of how large language models are trained. So this example is developed by Emily Thomforde from the California Department of Education. This demonstration was actually developed for children. However, I still think the principles and the way that it's explained is appropriate for all ages. So the example we have here explains how large language models are trained to provide textual responses or from prompts. These are trained on very large pieces of data. However, in this example, we are actually just training on one piece of text, which is Dr. Seuss's poem, Green Eggs and Ham. So the demonstration is designed to be interactive, but what you might want to do is pause the video at times to answer the questions that you see on your screen. So large language models are very advanced versions of autocomplete that you see on your phones, but way more smarter. They predict the next word that you see or based on a string of text. So this is similar to what you see on the phone, but what's actually looking at is more the context as well. So in this demonstration, we're going to be looking at a poem, one poem, but we're looking at a poem that has a lot of repetition in it. That's because large language models work really well when it comes to noticing and learning from patterns. So repetition helps a large language model to understand and predict the text better because they're designed to recognize when words are more likely to come after each other. So large language models learn from reading those billions of text, and they look for things like the grammar and the word meanings, and also about thinking about how words are related to each other to build these the text that you see. So they do this by keeping track of how certain words follow each other, and that they use this information to make guesses, okay? So it's all about probability and the probability of one word appearing after the other. So once they've learned enough, a large language model can create its own text because what they're looking at is the words that you give them, the prompt, okay, and learning and figuring out what the words should come next. So this is why they can make those texts make really good sense and fit the context is through this process. So this demonstration gives us a little bit of insight about how this works. So as I said, we're going to be using Dr. Seuss's Green Eggs and Ham for our demonstration. And so we're going to work through this poem line by line. And what we're doing is we're drawing each word in what we call a node, and the association is represented by a line between each word. And so as we move through this poem, we're going to see stronger association between some words and then others. So in our first sentence, we see I am Sam. So what we put is each word in a separate node and linkage and the lines between them. So it shows the associations. You also see a full stop. So large language models also manage grammar and punctuation. It's a very sophisticated way that they do it. And so for the purpose of this demonstration, we're not going to be looking at punctuation. We'll be looking more at the word associations, but it's very fascinating how punctuation works in large language models. So moving on. So the next line of I am Sam is that I am Sam. So what we're seeing in this in our model is that there's a stronger association between the words, and to represent that association, I'm just making the line between each word slightly thicker, slightly darker. Next, we see a new line, a new pathway. So I do not like that Sam I am. So what we see here is that there is now an alternative pathway between I am to I do. So looking at that, what do you think would be the most likely pathway, the highest probability between if I type in I? Which pathway will it go? It will be the first pathway. So I am Sam, because it's seen that twice as more than I do onwards. So what we've seen here is that the association has built, it's been stronger in that link. So we're more likely to see the likelihood of I am Sam. But as we move on, we see more sentences, and in particular, this sentence is again reinforcing the I do not like, okay, relationship. And what we've got here is I do not like, and now an additional them pathway. So now looking at our new pathway, how has it changed? What is the pathway through? Would I take an alternative path? What's the probability of that? So if I was looking between the two pathways, I am and I do, they are equally as likely because they are strong, equally as strong. If they go down to I do not like, okay, that and them will be has an equal chance of being displayed. Moving on. So I do not like green eggs and ham. So what we see here is the strengthening of the relationship I do not like. So because now we've seen it 3 times compared to I am Sam, which has only been shown twice. In the next sentence, we have 2. I do not like them here, there, or here or there, and I do not like them anywhere. And so this new alternative path is, we haven't seen it as quite as much as I do, but is as much as I am at least. Okay, so that's what's changed. So which path am I going to probably go down? What's the highest probability? That second pathway. I do not like them. Okay, and then Sam I am, here or there or anywhere are equally as likely. So hopefully you're now seeing the pattern that's going on. So as we go through the model, it grows and grows, and there is stronger and stronger relationship between certain words. In particular, I do not like is getting stronger. And also, I would not eat has also come up. So the like is still stronger, but now we've got an eat as well. So as the poem goes on, there is more variation. And now we sing, I do not like them in a box. I do not like them with a fox. I do not like them in a house. So the I do not has become more dominant because we are seeing that more and more. So hopefully you're starting to see that pattern in terms of how the association between the words are starting to be built. However, if you are familiar with Dr. Seuss's poem, you'll also recognize that there is a bit of a plot twist in the poem. And when we get down to the end, you will actually see that Sam has tried the green eggs and ham and realized that they did, or he or she liked the green eggs and ham. So that's when we start to see, I would eat them. I would eat them in a boat. I would eat them in a goat, with a goat, sorry, not in a goat. I will eat them in the train, in the dark on a train. I will eat them with a fox. I will eat them in a house. So what we're seeing now is a bit of a change in terms of the repetition, but what we're also seeing is a change in the meaning of the text. So thinking about that, how do you think the model will change? So what we now see is alternative pathways to not I don't like them, I won't eat them, to now I would eat them. However, now what we know about how large language models work, and it's around the association of repetition. Do you think this is going to change the probability of our pathways? So with that new change between I will, okay, is it changing the probability or the most likely path? So let me ask that in a slightly different way. So if this was the large language model that underpinned ChatGPT, and we typed in a question of, would Sam like green eggs and ham? What do you think the likely response would be? The likely response is that he wouldn't like it, because what's happened in our poem is the dominant statements are I don't, I don't, I won't. It doesn't matter that Sam changed his mind later on. It has no context of timing in it. It's more around the associations, the probability, the linkage between words. So this is the fundamental thing to think about when we're talking about large language models. Okay, the fundamental thing is that they built on the likelihood of those word associations, and that's the highest probability of one word following another. So this is highlighted also in video 1, where Tim Allen talks about models that are underpinned by large language models, and him saying that they're developed using random generation function. And what he means by that is that these large language models are not governed by truth or reality, okay, but rather the linkage between words and how they are actually grouped together. Okay, so this is the focus of a large language model, is the plausibility of the text, not the accuracy. So hopefully through that demonstration, which I've gone through quite quickly, and it's a fairly simple example, but hopefully through looking at how large language models are developed, you can start to see some implications around what their limitations are. Okay, and in particular that large language models don't vet information. They just provide, what they think is a likely response, okay, that probability between words. And due to the probability of association, they don't think about, or well, don't consider the historical inaccuracies. So and they'll propagate this. And so that's why you see a lot of the time they would be talking about the responses are outdated ideas or historical stereotypes that are all propagated through this. So because that's, the data that it's been trained on. So large language models are not a context aware. They only make associations between the text. And so that's why we've got these issues, is because the majority of the written work is concentrated into the Western world and also historic. And so that's why we have one voice and one source of knowledge being dominated. And something that you can probably read a little bit more about if you're interested in that QR code link, which talks a little bit more around the generative AI for New Zealand, Aotearoa, about the idea that there are biases and implications, especially for Indigenous Māori language. So what we've got with large language models is that we've got this cultural or linguistic bias, and that information is trained on a body of text that is the largest body of text, which is that Western norms that come through. And this has huge implications on what information's being spouted out by these. And one of the examples here in that QR code that you can link that looks at large language models propagate race-based medicine talks about just one example of how large language models are actually have quite strong, are propagating harmful race-based or stereotyped medicine recommendations. And so you can read about that there. But the idea is that a lot of the time it's not just the content, but also how the information is displayed. And so the linguistic forms of the text has become more normalized. Also, just one last thing before I move on and we finish this video is that also how it's trained and the data that it's gathered. And because it gathers huge amounts of data, it doesn't necessarily worry about whose data that is. And so we've got issues around data sovereignty and how we protect information and writers and authors' rights, and something that that previous QR code also covers. So just to wrap up this video, just to highlight that AI, I've said this in the first video, is not magic. It's actually just maths. It's all about that probability. But hopefully through this video, you can start to see how large language models work, and therefore start to see some of those limitations and how probability and maths is the dominant form here, not, reality and truth and creativity. So hopefully that's been useful. Ka kite.